is B times A plus B. And in particular, we're going to let A be the cosecant squared of x. We're going to let B be 1, in which case A squared is the cosecant of the fourth of x. B squared is 1 squared. So that's, right now we have a number of fundamental identities, which again I can probably put over here someplace. I guess I can erase this now. We had something which connected the cotangent squared with the cosecant squared. Namely, it was the 1 plus the cotangent squared of x was equal to the cosecant squared of x. Or phrased differently, the cotangent squared of x was equal to the cosecant squared of x minus 1. So over here, we can write this as the cotangent squared of x times the cosecant squared of x plus 1 equals. All right, now I'm going to, use, instead of the cosecant squared of x, I'm going to write 1 plus the cotangent squared of x. And then I can pull together those two 1's and I get 2 plus the cotangent squared of x. That is 8.1 and 8.2. And on problem set 8.1, I want you to do problems 1, 5, 9 through 45. And on set 8.2, I also want you to work problems 1, 5, 9 out to 45. In other words, I want you to work every other problem. Now in chapter 8, for tomorrow's lesson, and later this week, on Friday, we're going to look at they carry through with this example, and they eventually come out with their answer on the next page. Now, without a doubt, that's the most complicated word problem. The other examples will start on page 259. Some of the even-numbered problems on page 263. So turn to page 263. The directions for the first set of problems are these. Without the use of a calculator, solve the following equations for exact non-negative values less than 360 degrees. So these are all look like rather simple problems, but the idea is that these simple problems can be applied in a more practical setting, which is may take 2 or 3 pages to express. I'm going to start with problem 2. All right, in problem 2, you're given that the tangent of theta minus the square root of 3 is equal to 0. And the question is, what is the angle theta? Well, the first step then would be to transfer the constant to the right side. So you have the tangent of theta is equal to the square root of 3. And you can easily draw a little triangle to remind you of what's going on here. That says that the side opposite divided by the side adjacent is the square root of 3. And if that's the case, then this is the 30-degree angle here. This is a 60-degree angle Whoops, just the opposite, right. So that tells us that theta is 60 degrees. It should be in the first quadrant. But we could also swing around to the third quadrant and pick up 240 degrees. Okay, in problem 4, we have 2 times the cosine of theta equals -1. Divide both sides through by 2, so you get the cosine of theta is equal to -1/2. Why don't you tell me what are the angles of theta? What's one angle? Possibly, but what about the angle? How many degrees do you need the angle? What quadrant would it be in? Second quadrant. So what would the reference be? 60 degrees. So what would the real angle be? 120 degrees. Now, okay, we can also swing down into the third quadrant. So what is problem 8? Or in problem 8, it says, without the use of a calculator, solve the following equations for exact non-negative values less than 2 pi radians. We have the square root of 3 times the cotangent of x is equal to -1. So the first step would be to divide both sides through by the square root of 3. So you would get this. Now, in what quadrants is the cotangent negative? Two and 4, that's right. And what would the reference angle be here? And then if you swing around into the fourth quadrant, what would the angle be? 330. Okay. All right, problem. And phrased differently, you could say that 1 is equal to -2 times the cosine of x, or that would be the same as to say that the cosine of x is equal to -1/2. Now at that point, we're back to where we were in problem 4, and you get exactly the same answers as we had in problem 4. So that would be a What'd you get? What's your wrong answer? That's the right answer, with one exception. You want a plus sign or a minus sign? Right, then you get the right answer. The answer is -21.8. Now let's go through this. First problem with this problem is that you have the cotangent instead of the tangent. Unless your calculator is different than mine, it has a sine and a cosine and a tangent, but it doesn't have a cotangent. Does anybody in the room has a cotangent function there? Yeah. So you have to turn that problem upside down. So you turn it upside down and you wind up with the tangent of theta is equal to minus 4/10. You all see that? Minus. So on your calculator, you should have minus 4/10. Then what you want to do is you want to get the inverse tangent. It depends on your own calculator what you have to do to do that. My calculator, you have to push a couple buttons. That's the division, I have to push one button. But you should come out with minus 21.8 degrees. Any question about that? Okay, let's do problem 16. Again, problem 16 is one where you have a function which is not on your calculator, namely the secant function. So you've got to turn things upside down and then use the functions which are on your calculator.